Hello, good morning, dear students. Today we are going to see Module 2. So, here I am using the book Introduction to Data Mining by Tan Steinbach and Vipin Kumar. So, this is just a revision of Module 2. So, here we are going to deal in detail regarding data. Okay, so coming to the next, what is a data? Collection of data objects and their attributes is nothing but a data. Okay, so an attribute is a property or characteristics of an object. What is an attribute? An attribute is a property of the or a characteristic of an object. Example: eye color of a person, temperature, etc. So attribute is also known as a variable, field, characteristic, or a feature. Okay, a collection of attributes describe an object. Okay, an object is also known as a record, point, case, sample, entity, or instance. So here at the right hand side you can see a table where you have a transaction IDs from 1 to 10, refund, yes, no in that form, Martial, their Martial status is single, married, divorced, and their taxable income, whether they are cheating or no. So this is a table that shows a particular person is paying a tax or no. So refund is one attribute, material status is another attribute, taxable income is another attribute, and cheating is another attribute. So all these things represent a collection of attribute that describe a particular object. Okay, so next, attribute values. Attribute values are numbers or symbol assigned to an attribute. What is an attribute value? An attribute value are there either numbers or symbols assigned to a particular attribute. So distinction between attribute and attribute value. So now what is the distinction between an attribute and attribute value? Same attribute can be mapped to different attribute values. Example, height can be measured in feet as well as it is in meters. So here height is the same attribute but it is mapped in different attributes in feet or is in meters. So different attributes can be mapped to the same set of values. Another attribute value how we can assign is different attributes can be mapped to the same set of values. Example, attribute values of ID and age are integers. So here ID of a particular person is also an integer, age is also an integer, but properties of the attribute values can be different. Property of an ID is different, whereas property of age is also a different part. So now another example, let us take a measurement of the length. So the way you measure an attribute is somewhat may not match the attribute properties. For example, at the first point if you say 1, A, if you take the length of A, where on the right hand side it is represented as 1, where on the left hand side it is represented as 5. The same length on the right hand side is giving a value of 1 and the same length on the left hand side is giving a value of 5. Now coming to the E, the length of E is giving a value of 5 at the right hand side where it is giving a value of 15 on the left hand side. So this is how we map a particular value to an attribute. Next, coming to the different types of the attributes. There are different types of the attributes. One is nominal. Examples of the nominal attributes include ID numbers, eye color, zip codes. Next, ordinal attributes. Example, ranking. Example, taste of potato chips on a scale from 1 to 10. So how you are going to rate the taste of a potato on a scale of 1 to 10? That is an ordinal. Either you may have 1, 2, 4, 6, 9 and so on. Height. Height is also an ordinal attribute where you can call a person's by seeing the height of the person you can call it as a tall or you can call him as a medium, or you can call him as a short. Next, coming to the interval. Interval is again a different type of an attribute. Example, calendar dates. So that is from 1st April to 14th April. That is one interval where, now, for example, you can take our country is in a lockdown state. Temperature in Celsius. So temperature varies from yesterday to what will be temperature of this week from 1st of April to the 14th April. That is either you can measure in Celsius or you can measure in Fahrenheit. Ratio, example, temperature in Kelvin, length, time, cons are an examples of ratio type of attributes. Now, properties of an attribute values. The type of an attribute depends on which of the following property it possesses. Distinctness. So either it is equal or it is not equal. Order, either it is less than or greater than. Addition, plus or minus. Multiplication, either multiplication or division. Nominal attributes. So here, if you now we will compare both the things. So nominal attributes represents distinctness, ordinal attributes represent distinctness as well as order, interval attributes represent distinctness, order and addition, whereas ratio attributes represent all the four properties. Nominal attributes has only one property, that is distinctness, and order attributes, ordinal attributes is having two properties, distinctness and order, whereas interval attribute is having three properties, distinctness, order and addition, whereas the ratio attribute is having all four properties. Next, coming to the uh, attribute type, the description, example and how an operation we are doing. So now, nominal attributes, the value of a nominal attributes are just different names. Example, nominal attributes provides only enough information to distinguish one object from another object. That is either it is equal to or not equal to. Example, zip codes. Zip codes for every city, every uh, location, it is different code, whereas employee ID of a company is unique. Is also an example we can take. The university seat numbers of the students are also unique. Then eye color of every person is a different, and the sex, either you can have a male or a female. Operations, here what we can take nominal, here is mode or the entropy, contingency, correlation, etc. Next, if you take an example for ordinal attributes, the value of an ordinal attribute provides enough information to order the objects. So the ordinal attributes will give you an information regarding how I can order an object. Okay, and then hardness of a minerals. So whether it is good, better, or the best. Grades that we can give, for example, the grades what you get in exams. Okay, CGPA or SGPA is also number. The same thing is an ordinal attribute. Street numbers is also an ordinal numbers. So here operations are median, percentiles, rank correlations, run tests, sign tests. Next is interval. For interval attributes, the difference between values are meaningful. Unit of measurement exists either plus or minus. So that is again same example of the calendar dates. Temperature in Celsius or Fahrenheit. Here the operations utilized used are mean, standard deviation, Pearson's correlation, T and F tests. Next, coming to the ratio. For ratio variable, both differences and ratios are meaningful. It is multiplication and division, temperature in kelvins, monetary quantities, counts, age, mass, length, electrical current. Geometric mean, operations here is geometric mean, harmonic mean, and percent variation. Next, coming to the some more type of examples. Attribute levels, nominal, if you take a nominal attribute, any permutation of value. If all employee ID numbers were as reassigned, Would it make any difference? No, it is not going to make any difference, because everybody's ID is changed again. Everyone will have a unique ID, so it will not make any variation. So that is a permutation of those IDs. Ordinal and order preserving change of a value. New value equal to f. F is a function, as a some monotonic function, as an old value. So old value is taken, and I'm applying a function f onto that and generating a new value. Okay, so comments and attribute encompassing the notion of good, better, best can be represented equally well by the values 1, 2, or 3, or zero point 0.5 and 1, and so on. Interval, new value equal to a star, it's a into old value plus b, wherein a and b are the constants. So, interval, how we can define a new value that is equal to old value multiplied with a and plus and added with b, where a and b are the constants. Thus, the Fahrenheit and Celsius temperature scales differ in terms where their zero values is and where is the size of the unit. Ratio, new value is equal to a into old value, that gives a length can be measured in meters as a feet, that is the ratio. Next, coming to the what is the discrete and continuous attributes. Discrete attributes is having has only a finite or countably infinite set of values. Infinite, that is a finite values. Example, discrete attributes, zip codes, counts, or a set of words in a collection of documents, often represented as an integer variable. Note, binary attributes are a special case of discrete attributes. Binary values as a 0 or 1 as an example of discrete attributes. Continuous attributes has real numbers as attribute values. As now you can see the difference between here. The discrete attributes have only binary values, whereas continuous attributes is having both, is having real numbers as an attribute values. Example, temperature, height, or weight. Practically, real values can only be measured and represented using a finite number of digits. So how we are going to? So as continuous attributes are having real values, so here the values we can represent it is only using a finite number of digits. Okay, continuous attributes can also be represented by floating point variables also. Okay, next coming to the types of data sets. So three types of the data sets. One is the record, another is a graph, and third one is an ordered. Record, data matrix. Examples of the record is a data matrix, document data, transaction data, that is a bank transaction, graph, a World Wide Web, molecular structure of a particular chemical. Okay, so then ordered spatial data, temporal data, or a sequential data, or it may be a genetic sequence data. Next, coming to the important characteristics of a structured data.